Okay, so now I think it is the time that we're gonna get started. Okay, everyone, welcome to today's HFM Webinar. I'm your host, Alan, and I'm the International Sales at HFM, and with the background in chemistry, mechanics, and environmental engineering. And before we present all stuff for you today, I would like to let you know how this is working, okay? So first of all the attendees will be muted during the webinar, but you can still text in the chat bar. And what's more, the attendees are not able to chat with each other, but the attendees can chat with the host so that we could hear your voice and discuss some points. And at the end of this webinar, we have a Q&A part. And in this part, we are probably not picking up all questions from you guys due to the limited time, but you can send us those questions after the webinar also. And now let me introduce you our main speaker, Mr. Gabriel, the handsome guy sitting next to me. Hi, Gabriel.
Hi, good to have friends like this.
Okay, so Gabriel is sales intern at HFM, and at the same time, he's also the master student of international business at Beijing Foreign Studies University. And personally speaking, I really appreciate that you could be here with us and will share with us something really valuable. Thank you, Gabriel.
I can say exactly the same. It's such an honor to be with you here. It's such an honor to be representing HFM here today.
Okay, thank you. Okay, so we also have Stephen, our special guest today. Hi, Stephen. Hi, Stephen. I think you muted yourself. Could you please unmute yourself? Hello, Stephen. Can you hear me? Okay, I think there's some technical problem. Okay, no problem. I will do the introduction of Stephen. And Stephen has more than 8 years of experience in plate heat exchanger design and also providing really strong support to the thermal engineering solutions. And at the same time, Stephen plays a really important role driving the HFM technology and products innovation. And what's more, Stephen will join us at the end of this webinar in the Q&A part. And here is the agenda of today's webinar. We have totally 9 parts, but this whole webinar will be really informative, personally speaking, and we will see. Okay. So, So Gabriel, to be honest, I'm really curious about today's content because as we all know, oil and gas is a definitely attractive topic, especially in today's world, because oil and gas is still the dominated resource of energy in today's world. And I really want to know where and how our products, the heat exchangers, could be utilized in this industry. So Gabriel, please go ahead and start with your presentation.
Thank you so much, Alan. Thank you so much for this amazing introduction. I would also like to thank all the participants for joining us today. So my greetings to all of you who are in many different parts of the world today. So as you said, the plate heat exchangers are quite important for the oil and gas industry, and the oil and gas industry is quite important for many other economic sectors as well. Yes. But before we talk about how they are used in this industry, it's also important to make a little introduction about what the plate heat exchangers are in the first place, so that everyone have the same baseline and we can keep going the conversation and keep understanding everything. So let's go. So basically, the plate heat exchangers are heat exchangers basically made by plates, but they are the heat exchangers are a device made to promote the heat transfer between 2 fluids or more fluids. So it's quite important in the oil and gas industry, specifically because the oil and gas industry has a lot of chemical reactions.
Yes, exactly.
And these reactions, they have optimal temperature many times. So it's important for us to have this temperature management so that we can ensure the maximum efficiency in all the processes that are going to happen in the oil and gas industry. But just to remember, this session here is going to have a lot of information, but it's still a very summary of everything that has in this industry. So let's keep going on that. But before we talk, I still like to introduce the different kinds of heat exchangers, plate heat exchangers specifically. The first one and the most one of the most economical ones are the gasket plate heat exchanger. For example, I have in my hands a miniature of one of them. You see, so these are the plate heat exchangers called plates because you can see it's composed by many different corrugated plates, metal plates. They are put in series right here, and I have here this plate right here.
They're so cute.
Yeah. Even have our logo in them.
Yeah.
So here we see the plate itself, and this black thing is the gasket. So basically what happens is the following thing. For example, there's a fluid that's gonna enter this hole, is gonna spread all over the plate and go back to this hole right down here. Okay, this is the first fluid. Let's say the hot fluid. Okay. So, but in the following plate, as you can see, there is another one. Cold fluid, and this time this is going from the bottom to the top. It enters here, spreads to the plate, and goes out in this other hole. And meanwhile, the other fluid is passing inside this little ring right here. So it ensures that the fluids are not gonna mix it between each other, but they're gonna exchange heat between the plates. And that's how it works. So you can see we have a sequence of plates. So that's how it works. And it makes it easier for the energy and consequently the heat to exchange between both the fluids. And that's how the gasket plate heat exchanger works. But there are other kinds of plate heat exchangers. For example, sorry, not passing. Okay, the full weld plate heat exchanger. This time, instead of having like this gasket isolating the fluids, these plates are gonna be welded either by laser or argon arc. And this is made because many times some fluids are not very suitable for the use of gaskets, and because sometimes the temperature or the pressure is too high for the gaskets to support. So it makes more sense for us to use the full welded plate heat exchanger. So now we also have the semi-welded one, where generally it happens when one of the fluids is not very suitable for the gaskets, but the other one is.
Okay, but I have a question for this.
Sure.
So could you give me an example of this kind of fluid which is not suitable for the gasket?
Okay, one of the most common fluids is ammonia.
Ammonia.
Okay. Yeah,
okay.
ammonia is one of the fluids that is not very suitable for the gasket.
Okay.
That's the reason why we use when the other fluid is suitable for sure. We use the semi-welded. But here in this presentation, we're going to talk about a refrigerant fluid that in which we have to use the semi-welded plate heat exchanger. So pay attention because during this presentation, we're going to talk about this.
Okay.
So as the name says by itself, it has this one is gasketed, but the following one would not be gasketed, it would be welded because it's going to have the fluid inside, this kind of fluid, ammonia, for example. The other ones will be gasketed again, and there it goes the system. So it's a kind of alternate series of these plates. And the condenser is a specific kind of them, but in this case, one of the fluids is going to be the steam, is going to enter the heat exchanger, is going to lose energy. This way, it's going to condensate, as the name says by itself. It's turning into a liquid. It's a specific kind of semi-welded plate heat exchanger that is also, we are also going to talk about it during this presentation. But okay, I talked a lot about the heat exchangers. Let's talk now about some of the process that we're here to present. Let's start with the pre-drilling process because majority of the oil reserves are actually under the surface, so we need to somehow take them out, pull them out, and the pre-drilling process also makes use of heat exchanger since the very beginning of the process. So here we have like a drilling operation. Sorry. So in order to make this drilling operation work, it's very useful for us to have a mud. We're gonna use the mud in the drilling operation and through it in a way that the drilling bit will be able to work better. And after that, the mud is gonna be pumped back.
Out?
Yeah, pumped out after passing through the soil in this case. And it's gonna be sent to a mud treatment system.
Okay.
Right? And after that, it goes to a heat exchanger because it has 115 degrees. This temperature is Actually, it gets hotter after being used in the drilling operation, but we need to reduce its temperature so that we can use it again. But before we talk about the use of the heat exchanger, I want to ask a question to the audience, actually.
Okay.
I want the audience to participate in it as well. So I want to ask, because we have this treatment system, but why this treatment system is necessary before we send the mud inside the heat exchanger? Let me find here the poll.
Okay, here we have a poll, and everybody could give you the answer.
And everybody, okay?
Okay, here I can see it.
Yeah.
And so I'm just wondering, what is this mud?
Okay.
And that's the basic point that we could figure out the answer, I think.
Sure. Well, basically there are two main kinds of mud, the water-based and the oil-based, but the composition of the mud is going to depend a lot on, how can I say, the necessities of the operation, what's going to be necessary, what's the characteristics of the soil, the characteristics of the machine. So there are many different kinds of mud, and the one we're going to be used, well, it's going to depend on the situation. But basically, they're both either water-based or oil-based.
Okay, I see there's many of us give the answers.
Should we end the poll now? Okay, we have like some questions here. Oh, some answers here.
Okay, time is up.
Okay, that's the end of it. Okay, so basically we have different answers actually.
Yes.
The majority of the people said because the impurities can accumulate inside the heat exchanger, and this, but this answer is correct, exactly. The point is that we do not, when the mud is pumped out of the soil, it brings with it some rock particles, sand, and stuff like that. And this stuff can accumulate inside the heat exchanger. And when it accumulates, it's going to affect the efficiency of the heat exchanger, as well as the working life of the heat exchanger. Well, because it reduces the temperature of the fluid, actually the heat exchange itself is going to reduce the temperature of the fluid. So that's the reason why it's not the point. The point here is about taking the impurities out of the mud. And because of the components of the fluid after drilling, sorry, hold on. Are not chemically suitable. Actually, if they're not chemically suitable, that's how we're going to select the materials. So if not chemically suitable, we need to use another material. So that's.
So you mean the material for the heat exchanger?
Yes, exactly. Because if they're not chemically suitable, we need to change the materials of the heat exchanger,
like plates and gaskets.
Yeah, exactly.
As per the working conditions.
Exactly. So here we go. Let's go back to the presentation. So we're going to use a kind of cooling fluid to reduce the temperature of the mud. It's going to be reduced by 75 degrees, and the mud can be used again. Just to make it clear, the heat exchanger is actually inside the mud treatment system.
Okay.
I just separate here so that it can be easier to understand.
Okay, so you mean the PHEs part of this system?
Yeah, exactly. They are treated and then they are sent to the heat exchanger to reduce its temperature so that it can be used again. And as we talked about, the material is titanium because many times there are some corrosive materials that cannot be used in this place. So that's the reason titanium is a very good material for the plate of the heat exchanger. Meanwhile, the gasket, that can be nitrile rubber, NBR, or EPDM.
Okay, so from the sales perspective, if we use the seawater as the fluid, we have to choose the titanium as the material plate.
Yeah. Or another one that is more resistant. I mean, it's going to depend on the situation. So, but let's keep going on, because now we're going to talk about the crude oil pretreatment. Okay. We have the oil, it's already out of the surface, but now we need to treat this oil so that we can make a better use of this oil. So here we have the crude oil. Generally, the temperature is going to be between 25 and 45 degrees Celsius. It's going to be sent to the first separator. And as the name says by itself, it's going to separate the oil from the gas and water. Well, it's not crude oil anymore. I'm going to call oil, but it's not completely treated, because in order to make a most efficient treatment for this oil, we need to raise its temperature to 100 degrees.
Okay.
And then we go. This oil is going to go to a heat exchanger, the first regenerator, where it's going to exchange heat with the treated oil at 100 degrees Celsius. So we're going to have as a result. I'm going to be talking, by the way, I'm going to be talking very soon about where this treated oil comes from, but let's wait for a while. Okay. Let's follow the journey of the oil itself. Okay, the treated oil is going to have its temperature reduced and the oil is going to have its temperature increased. But wait a minute, thermodynamics. We cannot, you cannot transfer all the temperature, the 100 degrees from the treated oil to the oil.
Yes, exactly.
So it's not going to be 100 degrees yet.
So we need to heat it up one more step.
Exactly. So we're going to go to a second regenerator. Meanwhile, the treated oil is going to go to a cooler so that it can reduce even more the temperature. In this second regenerator, we're going to use produced water. I'm going to talk about where this produced water comes from very soon as well.
Okay.
As well, 100 degrees. And as we just said, it's not enough. It's still not 100 degrees for the oil. So we generally use a final heater, okay, to continue the process. Sorry. So that it can finally be sent to the second separator when it achieves the optimal temperature. So now we can separate the oil, creating treated oil that is going to be used here again to the regenerator, so that part of this transfers, that is energy that was used, that is in the treated oil's temperature, is going to be sent to the crude oil again. And the treated oil can be passed through the other steps. The same thing, we're going to produce water. That's where this water comes from. And we're going to send this water to the cooler afterwards. So we're going to have fresh water to the cooling fluid, and we're going to have the treated crude oil to the storage tank, and we're going to have produced water. Generally acidic and salty, because you also have some components that are also present in the oil itself. Okay. So here we go. The material of this, the plates of this exchanger are generally titanium, because it's more resistant to corrosion because of the conditions of the oil, and how can I say? The gaskets are H and BR. But sometimes it's necessary to be C276, which is still more corrosion resistant than this one. So it also depends on the components of the oil, because oils are not the same, depending on the region where they are. And now we're going to have the second one, also the same materials as the first one. For the treated oil cooler and the produced water cooler, the materials of the gaskets can be NBR. And final heater, well, it's going to depend whether it's electric or not. Because, how can I say? As we can see here, just to make one thing clear, we have this outline, but this outline is also flexible. It doesn't have to be exactly like this. You understand, right?
This scheme is not fixed. It could be changed or adjusted.
Yeah, exactly. For example, the second generator is not used every time.
Okay. Why?
Because as you can see here, after passing the oil through the second generator, it still doesn't have 100 degrees. So we still have to use the final heater. But why do we use it? Because when we put them in the heat exchanger again, we are going to increase more the temperature, reducing the gap they need to achieve 100 degrees. By reducing the gap, we reduce the amount of energy that we need to increase the temperature of the oil. So this way we can save energy. Okay. But sometimes we also have other procedures happening in the platform that's going to make use of this water. So, oh, maybe this water is going to be more effective in this other process. So instead of using here, we just use the final heater and that's it. You see, it's way more flexible. Yes. And the engineers are also here to find the best solution for your case in Pokemon.
Okay, that's nice.
Yeah. Now let's talk about natural gas. You see the natural gas right here. Yes. Separated at the very beginning, but now we're going to talk a little more about how to treat the gas. We are going to talk about two processes actually. The first one is desulfurization. So we have the natural gas. It's going to be sent to an absorption tower, and it's going to interact with lean amine at 40 degrees. From this interaction, what we're going to have? We're going to have the treated gas and the rich amine. Which is the rich amine? Is basically the lean amine that got attached to the acid gases that are present in the natural gas, and we want to eliminate them. Okay, so we have the treated gas already, but if we are able to take this acid gas out of the rich amine, we can turn it into linamine again. And this way we can reuse them. You're gonna see how right now.
Okay.
That's how we're gonna talk about this process. So this rich amine is gonna be sent to a heat exchanger where it's gonna exchange heat with linamine. I'm gonna be talking very soon about where this linamine comes from. This boilinamine is about 120 degrees. So in the end, this is gonna be the final temperature. The linamine, as you can see, is still not at the 40 degrees that is necessary for it to interact in an optimal temperature with the natural gas. So we're gonna have to send it to another heat exchanger to reduce its temperature. So here we have the linamine cooler. As you can see, it's a gasket one. The cooling fluid is gonna be cooling water. So it's gonna reduce the temperature until we have the linamine at 40 degrees and we can use it in the absorption tower. But now let's talk about the rich amine. It's sent to the stripping tower where it's going to be separated into acid gas and linamine. But look at that. This linamine is going to be sent to a reboiler. And that is where the boiler mine comes from after passing through the reboiler. So you can see this boiler mine is the same rich amine that was used in the beginning. We are reusing the amine so that we can save resources this way. And the reboiler is also important so that the remaining acid gas can be pumped out of the gas and sent again to the stripping tower. Meanwhile, this acid gas is going to go to a condenser. As you can see, it's full welded, which is going to turn it into acid gas and acid water. The acid water, in this case, can be reused in the stripping tower unless it is too acidic. So now I'm going to talk about the
materials.
Exactly. As you can see, it's stainless steel, 316 generally for the plates. And you can notice that except the linamine cooler, all the others are full welded. The linamine cooler has a gasket in EPDM. So I want to ask the audience to check, because we talk about the differences between the different kind of heat exchangers. So I want to send a poll so that we can check. Hold on. Why? Hold on. Okay. Why the amine cooler is gasketed different from the others? So we will have some options about the possibilities why this one is different from the others. This gasket, meanwhile, all the others are full welded, as you can see from the image. Let me take some water meanwhile, while the people have time to answer.
Yes. Okay, our audience, they're so active.
Yeah. Oh, you have many answers already.
Yes.
Wow. Okay, I don't know whether I should continue with them because we have a lot. Okay, I see some people, the answers are not the same. Some people said because the temperature and the pressure of the heat exchanger is lower. And some people said all of them both. The majority, okay, 80%. Yeah, let me end the poll. Said because it's all of the both. And I need to say, yeah, all of the both. I mean, the gasket plate heat exchangers are easy to maintain, easy to clean up. They're cheaper, as we said in the beginning of the presentation. And as we said, the temperature and the pressure in the heat exchanger is lower. So it allows us to use this kind of heat exchanger, the gasket.
Okay, and actually those options are the advantages of gasket heat exchanger.
Exactly. You got the point. You got the point.
Okay.
So, hold up. Yeah, cheaper and easy to maintain. Meanwhile, all the others, high temperatures and full welded.
Okay.
Now, I want to talk. Almost forgot to say one thing. This process is called sulfurization because the main component of this acid gas is hydrogen sulfide.
Okay.
So that's the reason why it's called desulfurization. But it's not the only gas that is present in this. The only acid gas that is present in the natural gas in this case. But here we go. Let's talk about another gas, not an acid gas, but dehydration. How we can take it out, pump out the vapor of water that is present in the natural gas. Similarly to the previous process, now we're going to use 3-ethylene glycol. I'm going to talk PHE. Yeah, it's going to be way easier for us to speak with. Lean PHE.
Chemicals.
Yeah, 60%. is going to react with the natural gas, and this lean PEG is going to extract the vapor of water from the natural gas. So we're going to have the bitter gas and the rich PEG, similarly to the previous one. And this, similarly to the previous one, they're going to interact in another heat exchanger with lean PEG. This time it's 200 degrees. So after this interaction, we're going to have lean PEG with a smaller temperature and rich PEG at a higher temperature. And similarly to the previous one, the lean PEG still has to need to have its temperature reduced. So it's going to go to another cooler that's going to have fresh air, or so fresh water, or even air as the cooling medium. Yeah, the cooling fluid, so that it can reach the optimal temperature. And now let's follow the rich PEG. It's going to a stripper reboiler, where it's going to separate into lean PEG.
So that we can reuse this lean PEG, right?
Exactly. The rich PEG goes to the stripper, becomes lean, we reduce its temperature and use it again in the absorption tower. Perfectly. And they also produce the vapor of water. That's exactly the particles they were attaching to the lean PEG. So it goes to a condenser and generates water in the end. So the materials are also stainless steel, but this time we have something different. Alan, you've been asking me a lot of questions. I want to ask you a question as well.
Okay.
So all of them here, you remember the previous one, the desulfurization. The lean amine cooler, it was a gasket plate heat exchanger. But the lean TEG cooler is actually full welded. Okay. Do you have any idea why?
That's a really good question, because I noticed this point. Because as my experience, as you said, some gaskets are not suitable for the gas, some kind of fluid in the heat exchanger, and I think TEG is one of them. So that's why we use fully welded heat exchanger here.
Perfect. Exactly. That's a kind of a material that affect the gaskets. Yes. This way we need to avoid using gaskets for this for this kind of exchanger when we're using PEG. So there we go. Now we're going to talk about other systems that are present in the oil and gas offshore platforms. So here we go. Let me talk about this one. We'll have a cooling water cooler. As the name says by itself, it's going to cool the cooling water that's going to be used in many different processes in the oil and gas platform. So it's going to use seawater because it's an offshore platform generally. Yes. It's the most very available resource. This way is going to reduce the temperature of the cooling water, and the cooling water can be used, for example, for the hot water cooler. For example, the hot water that comes from the engine can have its temperature reduced by interacting with the cooling water. But it can also be used, for example, to reduce the temperature of lubricating oil that comes from the machine as well. So that's how it works. Like we have this system of heat exchangers to produce a cooling water. They're going to be used in many different operations in the oil and gas platforms. Now, I want you guys to pay attention to this one. You're going to have a condenser, okay? That's going to interact with the seawater as well. And this condenser is going to react with a refrigerant. This refrigerant is going to exchange heat with the seawater and go to an evaporator. In this evaporator, it's going to exchange energy with the chilled water. And this chilled water is going to exchange heat with the water for room cooling. Basically, we are transferring the energy from the seawater until the water for room cooling through this system. I'm going to be talking about this system very soon. And we also have the water for room heating, which is used this exchange, and we use like boiled water, for example, so that we can heat the room. So yeah, in some places it's necessary as well. So here we go. The material for the cooling water cooler is generally going to be titanium for the plate and NBR for the gaskets. For the hot water cooler and the lubricating oil, it's going to be stainless steel, either 304 or 316, and the gaskets in NBR. The condenser, it's going to be titanium. Regarding the gaskets, I'm going to be talking very soon about the gasket, okay? The evaporator is also going to be stainless steel. And the plate heat exchanger the remaining ones are going to be stainless steel and NBR and EPDM in the case of the one for water for room cooling, and the water for room heating is going to be EPDM. Okay. Okay, the gaskets, because both the evaporator and the condenser are actually semi-welded. So, because the refrigerant is not very suitable for the gaskets either. So, we're going to have the refrigerants inside how can I say, a welded plate, but we're also going to have a gasket for the still water in one case or the chilled water in the other case, but that's the point. In this part, in this ring, we are going to have a gasket, and the refrigerant is going to be passing through here. So the refrigerant somehow is still interacting with the gasket. But there's a specific gasket that we still can use, and we're going to use it very specifically for the ring. It's chloroprene or CR in this case. So all the gaskets, the filled gaskets here are going to be in NPR or APDM, but the ring, as you can see here in the image, the part in yellow, is going to be chloroprene so that it can resist the refrigerant. But now we talked a little about this in the beginning of how can I say, of our webinar, and I want to ask the audience again. Okay. Because almost all of these plate heat exchangers have the plates in stainless steel. But both the condenser and the cooling water cooler are in titanium. And that's exactly the point of our next poll. Let me share with you so that you can give your answer. Okay, launch the ball. Is it launched?
I don't think so. Maybe you can try again.
Okay, I think it's done.
Okay.
Okay, why the condenser and the cooling water cooler have plates in titanium? Because it's cheaper, the cheaper material available.
Cheap.
Don't give them the answers. Don't give them the answers yet. Okay, you already know.
Sorry, bad.
No worries. No worries. If they think your wisdom is like transporting here. That's amazing. So you also have the option, because this is the material that resists the corrosive force of the seawater, because its material allows a better heat exchange ratio, and because it is required by law. So we have some options here.
We will see.
Okay.
I think we could end the poll.
Sure. So let me, thanks. So here we end the poll. Actually, everyone got the right answer because it resists the corrosive effect of the seawater. That's the reason why you use this material for these heat exchangers. Okay. And now I want to talk a bit more about this outline. Hold on. Okay, now I can pass. As you can see, the cooling water can be used in many different processes. And that's exactly the reason why we have this system. Because if all of this, the lubricating oil, the hot water cooler, if all of them were in titanium, it's going to cost more. That's the reason why we need this cooler in titanium, so that the other ones can be in stainless steel. But for the one, now I'm going to ask you something.
Okay.
For this one, for the hot water from the engine, the lubricating oil, they only have like 2 heat exchangers in sequence.
Yes.
But for the water for room cooling, we have 3. Yes. 3 heat exchangers in sequence. Do you have any idea about why we have 3 instead of 2 in this case?
Okay, as I know, the dust is really easy to be accumulated inside the system, especially HVAC system. And I think I would say that this is a kind of a system that could be avoid the dust accumulation inside of the system, especially for the evaporator. Is that correct?
You are absolutely right.
Yes, I'm
absolutely right. Both, not only the room cooling, also the heating cooling, it also can accumulate a lot of dust. Okay. And this dust is going to affect directly the evaporator. Okay. Which is compact and hard maintenance. So making maintenance with this kind of equipment and having a lot of dust is going to be very inconvenient. That's the reason why we have this chilled water as a clean medium between, so that we can facilitate the process. So basically, As I said, many of these processes are very flexible, and Hoffman is here to find the best solution for you, the solution that better fits, the best heat exchangers, the best combination of them. We are here to help you out and find the good solution for you in the oil and gas system and many other systems that we have in the oil and gas. This is just a summary, as we always say. There are many more details. You can be the entire day talking about them.
Okay, Hoffman is always on the way to find the better, the perfect solutions for you.
Absolutely, absolutely. But now I want to talk a little bit about the common issues in real life.
Okay.
The most common issues that people might have already noticed are leaks and corrosion. And I want to ask people a final poll in our webinar about, about why these issues tend to happen. What are the main causes of leaks and corrosion in plate heat exchanger? You would have some possibilities: gasket fails, a broken plate causing leaks, unsuitable plate materials, clamping size is not enough.
Yes, those are really common issues.
Yeah, exactly. And here, you already have some people answering. Hold on.
I think the correct answer is really obvious.
Yeah. Yeah, exactly. But that's good. That's good. It's more, but it's good that people can participate. It shows that people are paying attention to the webinar today.
Okay. Let's see.
Here we have, yeah, 100% got it right.
Yes.
It's all of the above. I mean, the gasket fails can cause leak for sure, because the gaskets are the thing that keeps the fluid isolated. So if they fail, for sure it's gonna be a leak. Broken plates as well, like unsuitable materials. We talked a lot about that. For example, in the case of titanium and the alloy as well, and unsuitable plate materials, and also the clamping size. Just making sure. The clamp is, yeah, the clamping size. The clamp is like this structure here in the heat exchanger. So yeah, these are the clamps. So yeah. Hold on. Here we can see the first picture from the left to the right. We have a clear leak. Is in this part of the heat exchanger. I don't know whether you guys can see, like here behind.
Carrying bar.
Yeah.
Okay.
Exactly.
So this picture is literally a disaster.
Yeah, for sure. I mean, this is exactly what we don't want to happen.
Yes.
Yeah, like right here. I don't know whether this one is clear to see. So yeah. In the other case, the following picture going to the right, we have like a leak that caused corrosion. So many times they're actually connected. In the third picture is interesting, because you can see that here we have the gasket, and the gasket should be responsible for keeping the fluid inside this kind of area.
Yes.
So as you can see, we can see black here and black outside of the gasket, which indicates that there was a leak in this plate. And the final picture for sure is another case of a corrosion that was also caused by a leak. But hopefully we here take all the necessary steps to avoid this to happen. We have our own software, as you can see in the first picture in your left, so that we can make all the simulations and analyze the materials, analyze the dynamics of the fluid, everything else, provide you the right solution, and so that you can design the right solution for you too, depending on your own and unique requirements. Here at the top, we can see one of our collaborators, that is doing the density test for the gasket. In the computer, the same person taking the, how can I say, testing the strength of the gaskets as well. And the final picture is about a PMI test, so that you can test the purity of the materials in the plate, so that we can ensure the quality of the materials that are in this plate. So
you mean we are testing the components, the content of components in the plates?
Exactly, exactly. So that we can ensure that the components is suitable for the requirements of our customers.
Got it.
But now let's talk a little more about Hoffman itself. We talked a lot about the points, and let's talk about what Hoffman does.
Okay.
First of all, these are some of our products. I mean, some of them you're already familiarized with them: the gasket plate heat exchanger, the full welded plate heat exchanger. But we also have all the products such as the braze heat exchanger, the plated shell heat exchanger, the stainless steel plate heat exchanger that is quite used for example, the food
industry.
Yeah, exactly. So we have many different kinds of solutions that for different industries. So we are here to find the best one for you.
It's nice.
Yeah. And we actually have the HFM Select. We can find it in our website, where you can enter some of the requirements of your project. And this program is gonna facilitate your choice
Mhm.
for the best options for heat exchangers in accordance to your requirements and the conditions of your product. You can check it in our website.
Okay.
And some of our services, for sure, we have local logistics, trainings, PHE design as well. Our shop. We also have like even souvenirs, for example. So if you want like a plate heat exchanger, you can also find it in our store.
Shop.
Yeah, exactly. Like,
And the color can be customized.
yeah.
Customized.
So yeah. And we also today we talk a lot about the oil and gas industry, but we are present in many different areas. Our engineers are specialized in many different areas, not only oil and gas, but LNG, fuel cell, power plant, petrochemical, solar power, metallurgy, and even as we talked about before, like oil, the food industry, refrigeration, paper pulp, HVAC, as you talked about as well. So there's like a universe of possibilities.
Yes.
That Pokemon can help you in your business. So these are some of our certificates. Yeah.
Okay.
3A, ISO, and many others that validate our commitment to quality and the customer satisfaction. Yeah. And these are some of the customers that trust us from the oil and gas industry. We have many others that in many other industries. So yeah.
But as I know, this is only part of our
Yeah,
customers.
for sure.
Yes.
We have like many loyal
Yes.
customers that it's good. It will take like another day for us to present all of them, and that's not the focus here today. So yeah. Now I would like to pass my word. I presented my part about the introduction, and now I want to know whether people have questions, and so that we can invite Stephen as well. So I'm very grateful for this opportunity of speaking to you today, and I give my word back to you. Thanks, Alan. Thanks for introducing.
Okay, thank you so much, Gabriel. Thank you for sharing all of this with us. And now is our Q&A part. You can ask the question freely by texting me. Okay. Okay, I will check the chat bar. Okay. Okay, here I got a question. As I said, so because we have a limited time, so we are now picking up all questions from our audience. So I will pick some valuable and good questions from the list. Okay, so in the chat room, I see there is a really good question. So it's about the natural gas treatment part. So the question is, the temperature is not that high, I think. Why need use fully welded heat exchanger? Okay, so first of all, let me switch to the page related to this question. Okay. So this part.
I think it's around 70.
17 or 60? 17.
I don't know. It's around.
Let me check.
Okay.
This one, right? Okay, I think
the question was about gas treatment.
Yes, natural.
Okay.
Natural gas treatment. Yes. Okay. Why we use the welded heat exchanger? And hello, Steven.
Hi, Alan.
I will share the screen. Have you heard about this question?
Can you repeat your question?
Okay, you repeat one more time. The question is about the audience think that the temperature is not that high, like 120, 100, 110. Why we use welded heat exchanger here? And they think that the temperature is not that high. Could you explain?
Okay, Alan. Okay. Yeah, the main reason for the lean and rich amine heat exchanger using a fully welded heat exchanger is that after absorbing hydrogen sulfide, the lean amine solution becomes rich in hydrogen sulfide. The hydrogen sulfide is a highly corrosive gas. This gas may cause the gasket setting to fail. So, in the petrochemical industry, containing with hydrogen sulfide. Engineers usually choose a fully well design because this design avoids the risk of gasket failure and improving equipment safety and reliability. But the lean amine does not contain hydrogen sulfide. So, and the cooling medium is water. So we can design a GPA gasket heat exchanger, amine cooler. Thanks, Alan.
Okay, thank you. Thank you, Stephen. I think you gave a perfect answer to this question. Okay, let's see. We get more questions. Okay. Okay, here I got one more question. It's a really good question. It says that how important is the integrity of the plates, and would cracks on the plates be a big issue? Stephen, I think it's better for you to answer this question.
Okay. The plate hole is very important. If the plates is broken in the heat transfer area, the heat changer will leaks. When the heat changer leaks, it will affect the heat changer efficiency, and it will influence the production. And when the crack occurs in the not in occur in the heat transfer area, this crack will affect the heat transfer's pressure. So and in the beverage and food industry, it will be very dangerous if the plates is crack. Thanks, Alan.
Okay, thank you, Stephen. I think you explained this question, the answer very well. And okay, let me see the next one. Okay, here I got one more questions. Why the remaining acidic gases after being removed when the lean amine passes through the reboiler is pumped back to the stripping tower instead of being pumped directly to the condenser? Okay, I think this question is related to this part, I think. So hold on, I will show you the slide. Okay. Oh, good. I think. Okay, this slide.
Yeah.
It's okay. So Stephen.
Okay, Alan.
Mm-hmm.
Yeah, this is a good question. Yeah, the lean amine solution, which comes out of the stripping char, also contains a small amount of acidic gas. So the reboiler will play an important role in this process. Vaporize the acidic gas again in the amine solution. Yeah, and then acidic gas entering the stripping char. These acidic gas come into contact with more amine solution, dissolve more acidic gas from the solution, for promoting the regeneration of the amine solution. So this process not only improves the utilization efficiency of the absorbent, but also ensures the stability and efficiency of natural gas desulfurization process. Thanks, Alan.
Okay, thank you, Stephen. Thank you. I think this point was explained very well. And let's go further. Okay. Okay. Okay, here I get one more. It's also about the acid gas. So the acid gas is composed mainly of hydrogen sulfide, but what are the other components of it? And what about the carbonic acid? Is it also removed in the desulfurization process? And personally speaking, this is a really good question. And but Stephen, could you please give us a more comprehensive answer for that?
Yes, Alan, you're right. Yes, acidic gas also
Here is the
contains.
carbonic acid.
Yeah, this acidic gas also contains carbon dioxide. The carbon dioxide is also a chemical acetic gas. So when the process is working on, both hydrogen sulfide, carbon dioxide, and other acetic gases will be removed. So that's why we say desulfurization and decarbonization, both for the acetic gas are removed. Thanks, Alan.
Okay, thank you. Thank you. Okay, here I guess, well, this question is really good. How can I get the code of your products? Okay, I could answer you this question. So there are many access to our platform or website. And first of all, you could send us an email directly, including all detailed description of your demand, and our sales will get in touch with you. And or you could also call us directly. And I think we have already shared our contact in the chat bar. I think. Yes, yes. Yes, there are so many access to us. Okay, here is also our contact on the screen.
It's not showing.
It's not sharing?
No.
Okay, all right.
No.
No, it doesn't matter.
Let me.
We have already shared our contact in the group. No problem. Okay, and here I got a good question. One more good question. So does Hopeman also provide online trainings? I think the answer is definitely yes. And Stephen? Hello, Stephen. Could you introduce more about these online trainings?
Yes, Alan. Yeah, we can provide online trainings. Yeah, we can provide trainings about project instructions, application instructions like today's introductions, and furthermore the heat exchanger design. Yes, yeah. If you guys don't know more about PHE, you can learn from Hoffman. Yeah, if you are an expert in no matter which aspect of heat exchanger, yeah, we can learn from each other. Yeah. Yeah, thanks, Alan.
Okay, thank you, thank you. So Hopeman could provide a really good service and support to our clients. So online training is not a problem. Okay, and time flies. I think the time is up.
Yeah.
Okay, so thank you guys. Thank you for your attention and thank you for your time to attend today's webinar. And thank you, Gabriel. Thank you, everyone. And so I think that's all for today. And if you have any further questions, just contact us. You could send us an email or call us directly. So anyway.
And send your questions as well to us because we're
Yes.
not able to answer all of them as well. So yeah, we are here to help you. And yeah, it was such a pleasure to be with you. And I'm really happy with the participative audience we had today.
Okay, so that's all for today. Thank you, guys. See you next time.
Bye. Bye.